Hello, in this video, we're going to be talking about the areas of circles and sectors. Okay, so first to define a word, this word sector is actually, if I were to take if I were to take a circle, like a pie or a pizza, and slice it out, right? One of these slices would be called a sector. Okay, so a sector is like a slice of a circle, but this vertex right here has to be at the center. Okay, it's not like you can slice your pizza or your pie or whatever it is off center. This part right here, that is called a sector. Your sector can be of any size, right? I could say that this part right here, all the way out here, more than half of the circle, this would be another sector. It would just have a different central angle measure, right? So this is another sector. Okay, so in order to find the area of a sector, we need to remember how to find the area of a circle. The area of a circle, if you recall the formula, is area equals pi r squared. R is the radius. Okay, so if you're given the diameter, you have to take the diameter and divide that by 2 in order to find the radius, and then you can plug that radius into your formula for the area of a circle. So we have two examples here. The area, we want to find each indicated measure. The area of a circle, that's what we're finding, with a radius of 2.5 centimeters. Okay, so for A, we want to find the area. If we know the radius is 2.5, so that's going to be area equals pi times 2.5 centimeters squared. Okay, now squaring a number means multiply it by itself. Area equals pi times 2.5 centimeters times 2.5 centimeters, right? Now, the reason that I did that is to emphasize the units. When you multiply centimeters times centimeters, that turns into centimeters squared, okay? So you could have an exact answer for this one of 6.25, because I multiplied 2.5 times 2.5. Keep the pi separate, centimeters squared, that would be exact. Or you could have the area is approximately 19.63 centimeters squared. Okay. For the other problem, part B, we want to find the diameter of a circle with an area of 113.1 square centimeters. Okay, so we know the area. So instead of using area equals pi r squared, I'm going to put, instead of the area, 113.1 equals pi times the radius squared. Okay, in order to solve this, I'm going to end up with the radius, and then I have to double that to get the diameter. So to solve this, I'm going to divide both sides by pi. Now, 113.1 is already a decimal. I'm not going to worry about an exact answer. I'm just going to go ahead and divide by pi to cancel out pi. Okay, when I do that, I get 36.00 and then some numbers after the decimal. I'm just going to call it 36 equals r squared, because then when I square root to get rid of this square, I'm just going to be able to say that r is 6 centimeters. Okay, we're not done yet though, because remember the problem is asking us for the diameter. So that means that the diameter is 12 centimeters. Okay, so let's apply area of a circle and use it in parts. Okay, so the area of this sector right here, is going to be part of the entire area of the circle. Okay, so this formula, the way that I remember it, is very similar to the formula for the length of an arc. Okay, I'm going to do the area of a sector the area of the sector equals the angle, the central angle, over 360 degrees times the area of my circle, pi r squared. Okay, so when I want to find the areas in this problem down here, now when they're saying areas, they mean both the blue part and the red part. I think that's supposed to be red. So this red part already has an angle marked at 70 degrees. I'm going to go ahead and find that one first. So the red part, the red sector, is going to be equal to that 70-degree angle over 360 degrees, and then times pi times the radius squared. Well, the radius is 8 inches, so 8 inches squared. Okay, and when you multiply that out, you get that the area of the red sector is approximately 39.1 square inches. Okay, now to find the area of the blue sector, I've got a couple of choices. I could do 360 minus 70 and find that that's 290 degrees, right? So I could do the area of the blue sector as 290 over 360 times pi times 8 inches squared, right? I could do all that, or I could take the area of the full circle minus the area of the red sector and get the area of the blue sector. Okay, now the area of the full circle, that's simple. That's just pi r squared, right? When you square 8, you get 64. Okay, in either case, when you find the area of this blue sector, you're going to find out that the area is approximately 162 square inches. Okay, let's talk about this thing called population density. Okay, population density of a city, county, or state is a measurement of how many people live within a given area, right? I could talk about the full population of, say, Colorado, right? But if I want to talk about population density, there are more people living closer together in the Denver area, like packed in, houses that are close together and in apartment complexes and all that kind of thing, than there are, say, in people who are living in Fort Morgan, where their homes are much farther apart and you've got vast amounts of just empty land with nobody living in it, right? So population density is how many people live in a certain area. Okay, so using the formula for population density, which is the number of people in total divided by the area of the land, we're going to do these two examples right here. Approximately 430,000 people live in a 5-mile radius of a city's town hall, right? So if you have the city town hall right here, that's the town hall, and a 5-mile radius, 5 miles, you have, that's a poorly drawn circle, but we get the idea. You have approximately 430,000 people living in this whole entire area, right? So since we're talking the area of a circle, the area of the land is going to be pi r squared. Okay, so we've got, for this first problem, we have 430,000 divided by pi times 5 miles squared. Okay, and when you multiply pi times 25 square miles, because 5 times 5 is 25, and then do the division, you get that this is approximately 5,474.93, but we can't have a part of a person, so we're going to round this, and we're going to say that this is 5,475 people per square mile, right? So if we broke this up into parts and had only 1 square mile, there would be about 5,475 people in 1 square mile. For the second part, a region with a 3-mile radius has a population density of about 6,195 people per square mile. So it's like they're giving us this answer. Find the number of people who live in the region, okay? So this is what they're actually giving us. 6,195 people equals, I don't know the full population, divided by, again, we need the area of that circle. So area is going to be pi times 3 miles squared, okay? So I'm going to go ahead and change this. So this is going to be 6,195 equals p over 9 pi. And then I'm going to multiply both sides by 9 pi times 9 pi so that I can cancel out those. And then I just entered this straight into the calculator, 9 times pi times 6,195. And I find out that this circle, right, with a 3-mile radius, in the entire circle, there's a total of 1,070 or 175,159 people. Not people per square mile, just people. All right. Now, let's jump to this one. We want to find the area of this sector. Okay? Find the area of circle V. So we are given that the area of the sector is 35 square miles. That's just the part of it. Like we were given part of the population density is just part of the population. We want to use that part to find the area of the whole entire thing. Okay? So if you remember, the area of a sector is your angle over 360 times pi r squared, the area of the whole circle, okay? This is what I'm looking for. I'm going to replace what I know. So the sector has an area of 35 square meters. The angle itself is 40 over 360. And I'm looking for the area of circle V. So I'm just going to look for times A. Okay? And when we take this fraction right here and we reduce that fraction, we find that it's 1 over 9. Okay? So this is going to be 35 equals 1 over 9 times A. And in order to remove this fraction from the variable, I'm going to multiply by the reciprocal, 9 over 1 times 9 over 1. So the fractions cancel. And then I find out that the area of the full circle is 315 square meters, right? Because this was square meters, so this is square meters. All right, one more. This time, let's actually apply all of this to something you would do in your house, painting a wall, okay? A rectangular wall has an entrance cut into it, right? So we've got a little doorway right there. I noticed that this doorway, the top of it is an arch, right? It's an arc, okay? So really what we've got going on is that this right here is a rectangle, and then this right here is half of a circle, okay? And that's being cut out of the wall. So we're not going to paint that doorway. We're just going to paint the wall that it's around it. So what I'm going to paint is pretending like it was a full wall, but subtracting out this bottom rectangle, and also subtracting out up here where we have half of a circle. Okay, so if I wanted to paint the whole entire wall that did not have a doorway in it, the whole entire wall would be 36 times 16 plus 10, which is 26. Okay, when I subtract out this doorway right here, right, the rectangle part is going to be 16 times 16. When I subtract out this half circle up here, I've got 1/2 times pi times the radius squared. So if it's 16 feet all the way across, that means that the diameter is 16 feet. And that means that the radius is actually 8. So pi times 8 squared. Okay. If we use a calculator to do some multiplying here, we've got that the area that we're going to paint is actually 936 minus 16 times 16 is 256 minus 1/2 of pi times 8 squared is going to be 100.53. Okay, and then when I plug that in and subtract, I get that the area that I'm going to paint has an area of 579.47 square feet. Okay, except I'm going to go back up and read the instructions. It says to the nearest square foot. So square foot means no decimals. Okay, if I'm going to round this properly, so properly rounded, 0.47 is less than half, so this would be 579 point, just 579 square feet. If I'm actually going to go to Lowe's or Home Depot or someplace and buy paint, to buy paint, always round up. Always round up. So I'm going to round this up to the next whole square foot and call this 580 square feet. Okay, so in your book, I would say to properly round it, put into your answer 579. But in real life, if you're going to go to a store and buy some paint, round it up to 580. Thank you for watching. I hope you learned more about circles.